Hello everyone and welcome to the webinar, Oracle Partitioning from 8 to 18. It just got better. My name is Gavin Soorma. So let's start and get into the presentation as soon as we can. So what is Oracle Partitioning? As the English dictionary suggests, it's to divide something larger into small parts or shares. Oracle Partitioning takes the very same concept, and it basically is functionality or a feature which logically divides large objects, which could be tables or indexes, into smaller pieces, and those pieces are partitioning. It's a key requirement for large databases. So as the volume of data increases, management of that data becomes more cumbersome because of the size, but we still need high availability and high performance regardless of the size of the database. So that's where partitioning really helps. And in most cases, we see that the partitioning strategy that people adopt will be driven by some kind of business requirements. So how do we use partitioning? Obviously, the volume of data has increased, and most of us DBAs have experienced that fact. The biggest challenge facing DBAs is how to manage these huge increase in volume of data, while at the same time ensuring that the business still has high availability, high performance. So with partitioning, what do we get and why do we use it? So we get performance because it lowers the data access time. So instead of accessing a whole table to basically run a query, the optimizer will access data at the partition level as opposed to the table level. So that's called partition pruning, and that leads to improved performance. We can also have higher availability with partition data because we can maybe place data in different table spaces. When I talk about data, I mean partitions in different table spaces, and those table spaces could be on different physical disks. And when we have some disk failure, rather than the whole table being not available to my end users or application, only a portion of the table will not be available. So that's restricted to the partition which is having some kind of problem. In terms of cost, it can also lower cost for enterprises that are using some kind of storage sharing, like maybe you have expensive storage, you have cheaper storage, and you partition your table now, and then you want to keep your older partitions, which typically has your archive data that is very rarely accessed on lower cost storage, and your more recent data that is volatile, that's being used all the time, instead of being deleted on higher end storage. And that's possible if you partition your table again and you place your partitions on the appropriate table spaces. In terms of implementation, partitioning is pretty much easy to implement. It doesn't need any kind of really make us have to change the application code in any way. And it's a very mature feature. So what we're going to see in this presentation is how partitioning has changed from version 8 that it was first introduced all the way until the very latest, which is Oracle 18c. So how does actually partitioning work? It's basically takes a large object. In this case, we see a large table called sales. One of the challenges of maintaining such a large table is obvious. So in terms of housekeeping, in terms of availability, in terms of performance, it poses challenges to the DBA. And the solution is basically using partitioning, and we are doing nothing but divide and conquer. And that provides us not only improved performance, but also easier data management. So here we have a sales table, and that sales table has been partitioned by maybe some kind of date column on the table. So we have data for Jan and Feb now in different partitions. And then we take it one step further, and we do what's called sub-partitioning as well. Maybe we have a requirement to partition the table not only by some kind of date column, like maybe order date or sales date, but we also have a requirement to sub-partition the data based on some kind of list of values. In this case, it's maybe region. So we will talk about this composite partitioning feature a bit later in the presentation, where we have a table that's partitioned by, say, range, which could be a date column, and it's further sub-partitioned by maybe a list of values or list partitioning. So partitioning provides us increased performance because it only works on data that's relevant. So when you talk about the optimizer, it does partitioning pruning for us. And not only is the optimizer providing us with the partition pruning and only selecting the partitions that are relevant for a particular query, but also other kinds of operations in terms of data management. So like housekeeping operations, rebuilding indexes, creating indexes, taking back. All that is significantly improved in terms of time and effort, because we are operating on lower volumes of data. So maybe instead of backing the entire table, we basically have partitions in different table spaces of that same table, and maybe they're taking the backup at the table space level as opposed to backing up the entire table. So all the operations happen at the partition level as opposed to the individual table level. So here's how partition pruning happens. So we have this table. It's pretty big. It contains data for many days, and here we see that every day is day's data is located in a different partition, and maybe we only require data for the 1st and 2nd of May. And when the query runs, optimizer will identify the partitions it needs to satisfy the query, and then as opposed to reading the entire table, it will then basically just do partition pruning and identify the partitions it needs to satisfy this particular query. I mentioned about this earlier. For organizations that adopt some kind of storage sharing, it may lead to decrease in cost for storage, because we can have the older partitions which contain data that is rarely used in table spaces, and those table spaces could be hosted on storage that is cheaper, as opposed to the more recent data or the more volatile data which is located in table spaces or partitions on more high-end storage. So partitions enables us to use this tiered storage type of model, and that can afford decreased costs for the organization. In terms of availability, partition not only reduces the maintenance window, so like we have some housekeeping tasks that have to be performed in the maintenance window, but because we are operating on partitions as opposed to the entire table, those maintenance windows are reduced, so increased availability. When we do a recovery, we can recover a particular partition if it's on a table space, and that table space is maybe located on maybe a different disk group, and only that particular disk group is impacted by some kind of media failure. So when we do a recover, we can recover the partition that has failed as opposed to recovering the entire table. So here is where I have multiple partitions, and only one on different disks, and only one disk is having some kind of failure, so only one partition is impacted. The other partitions are usable for the application. So typically the availability of my app is increased. So even though we've had a media failure, it's only impacted a small portion of the data that's restricted to the size of the partition. So partitioning, as I earlier mentioned, is very easy to implement, but keep in mind that it's a licensable feature. It's part of Enterprise Edition, so there is some additional cost of using partitioning. But in terms of changes to application, does it require any change? The answer is no. There are a number of different methods of partitioning tables, and we're going to see this in the course of this presentation. You have single level partitioning as well as composite level. So single level could be range list hash, and also all the other new methods that are introduced in subsequent versions of Oracle. We also have composite level partitioning. So it's taking the single level partitioning and doing it at another level. So that's called a sub-partition. So maybe you partition the table first by range, and then you sub-partition it by list. And there's lots of extensions to partitioning, as we will see. You have partitioning on virtual columns, you have reference partitioning, you have interval partitioning. So every successive version of Oracle has had new features of partitioning being introduced, and that's what we're going to see in the course of this presentation. So let's start off at the very beginning. So Oracle 8 was when range partitioning was first introduced, and range partitioning is basically just organizing data into ranges. So in this case, we have data being organized into partitions, and these partitions are based on, say, a month. So you have data for July 2014 in one partition, and data for September 2014 in another partition. And this is ideal for chronological data, all right? And in terms of partitioning, it's basically normally on tables that have some kind of date columns. And it's also one of the most common types of partitioning you will get to see. So what you can't have with partitioning by range is that there should not be gaps, all right? Along with the range partitioning, in the next version of Oracle, which was Oracle 8i, we also had concept of hash partitioning. So hash partitioning is ideal in those cases where we don't have any clear partitioning key that can be used in the table, or where the partition is not really historical in nature, but we still want to obtain benefits of partitioning data. So then we can partition this table by what's called hash partitioning, which is where Oracle will hashing algorithm, and they divide the data in the table into what's called hash buckets. And we can configure how many hash buckets or how many partitions are created. So it's ideal for those cases where a table is pretty big, but I don't have any clear candidate or column table on which to partition the table. By partitioning it by hash, I'm ensuring that I'm dividing the data now into equal data distribution among the different hash buckets that have been created by Oracle internally, and this ensures some kind of data distribution. So we take a key value, and Oracle will apply a hash function to that, and you can see out here the data has been divided into a number of hash buckets, and these hash buckets typically will equal the number of partitions. So that was Oracle 8, Oracle 8i, and then moving on to Oracle 9 was when another form of partitioning called list partitioning was introduced. So what the list partitioning does is that we have some kind of maybe list of value type of data, so data that's having few distinct values, but I would like to partition my data based on those list of values. So let's say maybe it's state, or maybe it's region, and those values are not really high in the particular table. Obviously, we don't have like millions of list partitions. So in this case, I have maybe customer data, and I want to basically partition it based on the country that customer is located in. So data is organized in this case based on some kind of list of values. So it's ideal for segmentation of data based on some kind of distinct value, which in this case is region. So data that is maybe unrelated and unordered, we can group and organize that data by using this method of partitioning, which is called list partitioning. So these were the initial methods of partitioning which came in Oracle 8 and Oracle 9. So we had the range partitioning, we had hash partitioning, and we also had the list partitioning. Moving on then, we came up to another version of partitioning, which is called the composite partitioning. So we had range, we had hash, we had list, and then there was a requirement maybe to sub-partition it a little further. So you have a table that's range partition, maybe now you want to hash partition it as well. So what the composite partitioning does, it basically organizes data based on 2 dimensions. So in this case, I have my data initially partitioned by some date column, so that was range partitioning. And now I have a further requirement to, like within each of my range partitions, I want to sub-partition the data. So for example, data for July 2014 is in a particular partition, but I also want now to split that partition into a number of sub-partitions that are based on maybe region or country. So here is a case of composite partitioning where I have initially partitioned by range, and then the sub-partition is happening based on list. So what does this give us? It provides higher level of partition pruning potentially for the optimizer and finer granularity of data placement through the sub-partitioning method that we are adopting for this particular table. So this is a table that has been composite partitioned, range-list. So the syntax would be like create table sales, partition by range, and then partition by list. So we're specifying the columns. So a time dimension column is being used for range, and a list value type column is being used for the list partition. Moving on to Oracle 11G, another method of partitioning was introduced called interval partitioning. The problem with the range partitioning was we always had to ensure there was a catch-all partition, which was the default partition, or we had to go and create a partition in advance of data actually being inserted into that partition. Because if, for example, we had partition our table until say December 31st, 2018, and now we moved into 2019, and through the application of new data is being inserted, if there was no default partition, the insert would basically fail because there's no partition available where this data can go. So what was introduced in Oracle 11 is the concept of interval partitioning, where Oracle will automatically create additional partitions for us as and when the data arrives. So initially my table is created with just one partition maybe, and as new data arrives into the table, automatically system generated partitions are created by Oracle based on the interval that we have specified. The interval could be a month, it could be a year, it could be a day, it could be a quarter. So it's up to us basically. So this is just an extension to range partitioning. So initially, I've created this table called sales, and it's partitioned by range. I specified the column, which is order date, and then I specify the type of interval partitioning. What's it based on? It's basically based on month. So every new month, a new partition will be created. So when I create the table initially, all I have to specify is the first partition, and then subsequent partitions are automatically created by Oracle as and when data for that particular month, in this case, arrives. So new partitions are automatically created when data for that particular partition is maybe inserted through the application. Along with the interval partitioning, another method of partitioning was the reference partitioning. That again was introduced in Oracle 11G. The concept is quite simple, that typically we have parent and child tables. The parent table is partitioned in a little column, and if you wanted to have the same kind of partition for the child, we also had to have the same column in the child table as well. So that led to some kind of redundancy in terms of storage, etc. So here we have the orders table, the line items table. So the order is the parent and the line items is the child. And the order is partitioned based on the order date, so that's range. But in this case, I also had to have the order date column present in the child table as well, to ensure the child table is partitioned the same way as the parent table is. So with the reference partitioning, I don't have to have that column in my child table. If I partition my table, my parent table based on a particular column, in this case it's order date, then my child table automatically inherits that kind of partitioning model from the parent. So you can see out here that data for the partitions now, sorry, the table is organized into partitions. And here in this case, the partitions are based on month. So I have data for September 2014 in one partition, and then October 2014 in another partition, and so on. But I also have my child table, which is line items in this case, also partitioned on the very same way. So if my parent table is partitioned in a particular way, the child table inherits the same kind of partitioning strategy. So that's the reference partitioning. So even though I don't have the order date column in my child, the child table is partitioned exactly the same as the parent. And that will very help in those cases because typically I'll query orders and the line items table together. So I want to ensure that data is organized efficiently in my child table as well, based on how the data is organized for the parent table. So quite a few new features in terms of partitioning was introduced into Oracle 11G, and another one of them was the concept of virtual column partitioning. So virtual columns were introduced with Oracle 11 as well, and these columns don't really exist in the table, but they're typically based on some kind of calculation. So in this case, we see that we have a column called region, which is derived as the substring of the ORA ID, and using 6,2 here, that means these two values are being taken as another column. So I pick out from the ORA ID this part. So US in this case, EU in this case, EU in this case, and US and US here. And then they become columns in my table. So there's part of my virtual column. But now I can use that column to also partition my table, because maybe I have a requirement to partition my table based on maybe order date. But I also I want to partition my table by region. So I'm doing a composite partitioning here, but the sub-partition here is based on a virtual column, which in this case is region. So I'm partitioning it by order date, region. So I'm using range dash virtual column partitioning now for my composite partitioning model. Let's have a look now at what was introduced with Oracle 12. So with Oracle 12c, we had interval reference partitioning. So we had interval partitioning earlier, we had reference partitioning, and taking this one step further in Oracle 12, we had a concept of interval reference partitioning. So what is that? So we have, again, parent-child concept. So we have maybe the orders table, and then we have associated child tables like back orders and line items. And the way the parent table is inheriting partitions as part of interval partitioning. So for every new month, a new partition gets created for the parent, but we also want to ensure that my child tables also have the same partitioning strategy applied to it. So as new partitions are being added on the parent, for all the child tables, similarly, new partitions are being created to keep it in sync with the parent. So this is called interval reference partitioning. So we had interval partitioning earlier, we had reference partitioning, and now this is combining the best of both here. So all child tables will get automatically maintained when the partitioning on the parent table changes. So basically, when new partitions are created, as new data arrives, through interval partitioning, additional partitions are created from the parent, and through reference partitioning, the same partitions get created on the child as well. So combination of interval and reference partitioning. Another concept of partial indexing was introduced with Oracle 12c, and we are taking that partial indexing concept towards to partitions as well. So typically what we would like to do is that if we have a table, and my table has both new data and old data in the same table, I can possibly partition my table and have a model of partial indexing, where my most recent data, which is being subject to a lot of DNA changes, does not have any indexes, and older data that's subject to some long-running queries does have some indexes on it. So I don't want to slow down my DML operations on the table by having additional indexes. So my new partitions that get created, maybe through interval partitioning, do not have any kind of indexes defined. So that's partial, but the rest of the table that has older data has indexes defined. So in earlier releases, we had to create the index. If my table had 10 partitions, and I could index. If it was local indexes, obviously, I would have 10 partitions as well. So I didn't have the option of saying, okay, I only want to partition, but I only want to index a portion of the data in my table. Now it's possible with the partial indexing that was introduced in Oracle 12 to only index a portion of the table data, and that's based on maybe some kind of business requirements. So index my historical data that's stored in older partitions. My new data is volatile. My system is old in nature. So do not index data in the newly created interval-based partitions. A lot of partition maintenance operations were enhanced in Oracle 12c. So let's have a look at some of those. So we have the concept of local indexes and global indexes. Local indexes means that the index is partitioned in the same column as the the same partitioning column as the table. So if my table had 10 partitions, my local index would also have 10 partitions. But with global indexes, it was slightly different. If my table had maybe 4 partitions, it's quite possible the column. The partition key of my index is not the same as the partition key of the table. The issue that was when we carried out some kind of partition maintenance operations, like drop partition or truncate partition, and used the clause like update indexes, the partition maintenance operation was not completed until the associated index operation was also completed. So that could actually took such partition maintenance operations. What has changed now with the Oracle? And I think in 12.2 or 18C, we'll have a look. I think in one of the subsequent slides, we'll see that this partition maintenance operation now is become an online operation as well. We can also move partitions online in Oracle 12. So maybe I have a requirement to archive my older data. I don't have to take any kind of coverage for this. I can move my partitions online to maybe some other kind of table space while concurrent DML and query activity was happening on the partition and the table as well. Introduced in Oracle 12c is the concept of cascading truncates. So if I go and say truncate my parent table's partition, okay, so I remove the Jan partition from say the orders table. So all table orders, truncate partition, partition name, cascade. Okay, what's going to happen in that case is that all the child tables that are dependent on this particular parent table will find that they don't have the Jan partition anymore because it's automatically being truncated there as well. So this cascading truncate is good because in a single atomic transaction, I'm able to preserve data integrity. I don't have to go to each individual child table and then drop that partition. So, or truncate that partition, because when the partition is getting truncated to the parent, it's cascading down to all the child tables as well. So that was 12.1. So let's look at what was introduced in Oracle 12.2. A good feature was the auto list partitioning. So list partitioning we saw was introduced, I think, in Oracle 9, but now very similar to the interval partitioning concept, where partitions get created automatically as data arrives. With the auto list partitioning, again, it's based on list of values, but when a new list, or sorry, new value that's not present in the list of values in the table is being inserted into the table, a partition is automatically getting created for that particular value to accommodate that. So this is an extension to list partitioning, and every distinct partitioning key will be stored in its own partition. So the bottom line is that very similar to interval partitioning, in for a list partition table, partitions are created automatically as the data arrives. Early on, the list partitioning could only be performed in one column, but now with 12.2, we have a concept of multi-column list partitioning, where I can basically organize the data based on a combination of columns record. This is the way maybe the application queries data. So we can see earlier we could only partition it based on a region, for example, USA, Germany, and Japan, for example, but now are also partitioning it based on another column. It could be like, I think this means the channel being used for sales, like direct or partners. So that's the second column that's being used to list partition this table. So I have the concept of multi-column list partitioning introduced with Oracle 12.2. Also in 12.2 is a new feature called filtered partition maintenance operations. So we do some kind of partition maintenance operations like move my partition to maybe older, move my older partitions to a different table space. And we said that possibly these table spaces are located in low-cost storage. But what we can do along with the partition maintenance operation, which in this case is a move partition, so moving my partition from table space active to table space archive, as part of that move partition operation, I can also filter some data. So you can see out here I'm specifying including rows where order state is equal to open. So only open orders gets archived, and what happens to the closed orders? They get purged. So I'm moving data and also filtering data at the same time as part of the move operation. So that is called filtered partition maintenance operation, new feature in 12.2. So early on, we used to have read-only table spaces, yes, and then we could put partitions in those table spaces, and they will inherit the read-only attribute from the table space. So if I wanted to have some read-only partitions and some read-write partitions, I have to simply set them up in different table spaces. Now with 12.2, I can have read-only partitions as well as read-write partitions, and they all could be located in the same table space. So I have 4 partitions out here located in table space TS1, and 3 of them are read-only and 1 of them is read-write. So I don't have to put them in separate read-only table spaces. Now the read-only or the read-write attribute is can be set at the partition level. I think one of the great features of 12.2, and this feature might really benefit a lot of people, is the online conversion of a non-partition table to a partition table. Doing this early on, we had to take outage, and it was not a straightforward operation to convert our table from non-partition to partition. Basically also what's happening now, it's totally online. It doesn't block any kind of DDL operations on the table, as well as any kind of DML operations on the table. So my table is being converted from a non-partition table. In this case, it's being converted to a list partition table, and it's happening online. So we have a table called sales area, all right? And we are basically altering the table later on, modifying it, and specifying the partition. So the sales table now is being partitioned list. So we're converting that sales table into a partition sales table now, and it's being done online. And we are also updating the indexes. That means if there were some indexes on the table, local indexes, they would become local partition indexes as well. So let's have a look now at some new features that have been introduced with Oracle 18c. So we know 18c is available for download for on-premise as well. So let's have a look at 3 of the new features in 18c as regards to partitioning. So the first one is called modifying the partition strategy. So in 12.2, we had the ability to convert a non-partition table to a partition table. What we can do now with 18c is change the partitioning strategy. So maybe the table was earlier partitioned by range. Now, due to some change in business requirements or application, we want to partition it now by list. So we can convert it from range partition to list partition table, and that can be done as part of the alter table modify partition statement. What's going to happen is that we don't need to take an outage for this, and the beauty of it is that this can be done online, while both queries as well as DML operations are happening on the table that has been modified in terms of the partitioning strategy. So what is happening here is that my partition tables are evolving without us having to manually go and recreate them. So I'm able to adjust the partitioning setup, which I have done on some kind of new business requirements, without me having to require some application downtime. So changing the partitioning strategy can be done online in 18c. Converting it from a non-partition to a partition table could also be done online in early versions like 12.2. So we saw a slide earlier that we could actually combine partition operations like merge into a single command. So merging partitions was introduced in Oracle 12c, but what is possible now is that same merging of partitions can be performed as an online operation. So we use the keyword online in the alter table merge partition or subpartition command, and this enables the online merge operation to be performed. So the concurrent DML operations along with queries on the partitions that are being merged is possible. Another good feature that has been introduced with 18c as regards partitioning is something called partition-wise operations. So typically we'll see in large tables that are being joined, the join is happening at the table level. So we have in data warehouses very big tables, and typically what happens is that we have some hash partitioning happening, where Oracle will take one table and build a hash table in memory, and then probe the other table for join for matching rows. With the partition-wise operations, what's going to happen now is that there is a significant reduction in the response time and also the CPU and memory requirements. And the joins are being performed not at the table level, but at the partition level. So I'm running a table in earlier versions, but now I'm basically doing the join at the partition level. So you'll see that hash joins are being performed. If you have a look at an explained plan, the hash joins are being performed now at the partition level. So also what this does is that it minimizes the amount of data that's exchanged when I have parallel execution servers operating and doing the joins in parallel. So this enables me to work with very large databases and process joins of large tables more efficiently. The partition-wise joins can be either full or partition. So when it's a full partition-wise join, it means that both the tables are partitioned. Okay, and the column has been used to partition the tables is nothing but the column that is joining both those tables, so the join key. In terms of the partition-wise, it means that only one table in the join is partitioned on the join key, and then Oracle database will decide which type of join to use. So the main thing that we need to keep in mind here is that it divides a large join that was earlier performed into smaller joins between pairs of partitions from the two join tables. So it's not just taking two tables and joining them. It looks at the partitions that are there in both the tables and then uses those partitions to actually perform a join. So let's have a look at the explain plan here. So I have an orders and the orders item table, and they have been partitioned based on the join column. In this case, it's order ID. But what we see here is this particular operation. So we can see that there's a partition range iteration operation, and then below that we have the hash join. So the hash join is occurring under the partition range iteration call here. And what's actually happening conceptually is that we start with the first partition in each table, do a hash join on that partition, then move into the next partition, and then do another hash join, and so on and so forth. So it's doing the joins now, not within two large tables, but between smaller chunks of data, and that is the hash partitions that Oracle will be actually working on, as opposed to the table. So that's called partition-wise joins. So guys, we have covered quite a lot of the new features that have been introduced all through different versions of the Oracle database, right from versions 8 until the latest version, which is 18C. I hope you have found the presentation informative. Thanks for attending the presentation. Please do contact me. You can get through it and spend him there. https://gavinsoorma.com, and would look forward to all kinds of feedback about this session. Thank you and have a good day.